Hi folks, it's Mrs McInnes here. Welcome to lesson 10, which is our last lesson in this trig part 2 topic. So in this lesson, I'm going to give you the worked solutions for the 3 past paper questions which are at the end of your notes. So the first question here, we have our triangle K, L and M. And we have our length, km, is 18 centimetres. And then we're told that sine of k is 0.4 and sine of L is 0.9. And we're asked to find the length of L to M. Now this question is a non-calculator question. It's from paper 1 of the past paper that it's from. So non-calculator. So the first thing we do with any trig questions is label our sides. So straight across from our capital letters, we'll do our small letters. We are being asked to find the length of L to M, which is that little side there marked as K. And then we've got to think about what have we been told. Well, we've been told the length of side L. And then we've been told that sine of angle K is 0.4 and sine of angle L is 0.9. So we do have some information about the angles at K and at L. So obviously, because the question is telling us sine of K and sine of L, it's going to be our sine rule that we use because that's the function that we've got in that information. And it's K and L that we have the two pairs, the angle and side matching pairs. So we're going to set this up as K over sine K equals L over sine L. So if we fill in our information, side K is that side LM that we're trying to find. So I'm going to write LM. Now sine of K is 0.4. So I'm going to write 0.4 there. For side L, we have 18, and then sine of L is 0.9. So I'm going to write 0.9 in there. Okay. So we need to now cross multiply this to solve. But what would make this easier to solve because it's non-calculator is to do any simplification that we can do. So the 18 over 0.9, we could simplify that fraction down, okay? We know that 9 fits into 18, so there must be a simplification that we can do there. But because it's 18 over 0.9, it's a little bit trickier than normal. So rather than going straight for the simplification, dividing the top and bottom by the same number, what I would say to do is multiply the top and bottom of the fraction by the same number to get rid of that decimal and then simplify it back down. So if I times the top and the bottom of this by 10, what I'm going to get is 180 on the top and then 9 on the bottom. I can now simplify that down much easier than if it was the decimal on the bottom. So 180 divided by 9 is 20. And that's now much easier to solve. So LM divided by 0.4. So if we multiply both sides by 0.4, we're going to get LM equals 20 times 0.4. So if you're multiplying anything by a multiple of 10, you split it up to make it easier for yourself. So times 20. All we would do is times by 10 and then times by 2. So 0.4 times 10 and then times 2. Okay, turn the multiplication around, split your 20 into 10 times 2. So 0.4 times 10 would be 4, and then times 2 would be 8. So 8 centimetres for that side. So the marks here, we get 1 mark for the correct substitution. So substituting the values into the sine rule in the correct places gets you your first mark. Then your next mark is for knowing how to solve. So starting to work through that cross multiplication. So you get a mark for knowing how to solve and then a mark for your final answer. So it's 3 marks in total. Okay, the next question we have here is a bit more involved. There's more writing, so we need to read through it really carefully and think, what is this telling us? So the question says, Katie and Mona are looking up at a hot air balloon. In the diagram below, K, M and B represent Katie, Mona and the balloon. The angle of elevation of the balloon from Katie is 52 degrees. So that just means from the ground looking up to where the balloon is 52 degrees. So we've got that angle at K. The angle of elevation of the balloon from Mona is 34 degrees. So we have that angle in at M. And then we're told that Katie and Mona are 350 metres apart on the level ground. So we've got that length at the bottom between K and M. We're being asked to calculate the height of the hot air balloon above the ground. So let's draw in what we're being asked to find. We're being asked to find the height. So the height is just that vertical height straight up there. So we have seen these questions before in our mixed trig questions where we need to find one other side of this triangle, and then we're going to use SOHCAHTOA within the right angle triangle to solve for that height. So let's start off with labelling our sides with our small letters. And in this case, I'm going to find this side over here marked with the K. So I'm going to find that side in my large triangle first, and then I'm going to use that right angle triangle that's made up with that height for, I'm going to use SOHCAHTOA to find my length in there. So there's your right angle there. So if I'm going to find side K, okay, let's think, do we have what we need to use our sine rule? So we have in here our matching angle that goes with the side K. So we have the 52 and the K, that's a pair. Now the only other side we have is that 350. We would need the angle up at B to do sine rule. And because we know two of the angles in the triangle, we can find that third angle. So the first thing we would need to do is 180 minus the 52 and minus the 34, which gives us an angle of 94 degrees at the top. So up the top, we've got 94. So we do have what we need for sine rule. So if we set this up, we have K over sine K, and we have B over sine B. So side K is the side I'm trying to find. So I'll leave that as a K for now. And then I have my angle at K, which is 52. So sine 52. Side B was 350, and then angle B we've just found is 94, so sine 94. So we're going to go ahead and solve this now. So cross multiply, starting with the unknown value. So K times sine 94 equals sine 52 times 350. So then the last step to find K would just be to divide by sine 94. So sine 52 times 350 divided by sine 94. So for side K, we have 276.5 metres. So now we can use that extra side that we found to find the height. So if I just take out the right angle triangle from the right hand side of that diagram, we're trying to find this height up the top. We've just found the hypotenuse, which is 276.5 metres, and the angle at the bottom was 34 degrees. So I can now use SOHCAHTOA to find this. So if we just write out SOHCAHTOA, in the triangle, from the angle that I have marked here, I have my opposite side and I have my hypotenuse. The last side at the bottom is your adjacent, but we don't need that in this case because there's nothing written there. So we have our opposite side is the side we're looking for. We have a value for the hypotenuse, so O and H. So if you look for which one has those two letters, it's SOH for sine. So our sum here will be sine x equals opposite over hypotenuse. So sine 34 is going to be h for height over 276.5. So our height will then be sine 34 times 276.5. So our height, we end up with an answer of 154.6 metres. Okay, so this question is 5 marks. It's a lot of marks. So your first mark is for your correct substitution into your sign rule. Your second mark is for knowing how to solve, so doing the cross multiply. And the last mark in that part is the final answer. And then mark 4 is for setting up your SOHCAHTOA calculation, and your 5th mark is for your final answer down the bottom. So 5 marks in total, which is quite a lot of marks. Okay, the last past paper question in your notes has some bearings involved. So here we have in the diagram below, D, E and F represent the positions of Dunbridge, Earlsford and Fairtown respectively. You're then told that Dunbridge is 15 kilometres west of Earlsford. So the fact that you're told there in the question that that is west, the first thing you should be thinking is that you know that that's a right angle there. And that's a right angle there, okay? If you have directions that you can use your compass points to do, so north, east, south and west, you can tell those degrees. So if something is west, we know that that's a right angle. We then have 2 bearings. So the bearing of Fairtown from Dunbridge is 126. So that is the full angle from north all the way round to that line is 126. And then you're told from Earlsford, the bearing of Fairtown is 230. So that's that big angle on the outside there's 230. So we're being asked to find the distance between Dunbridge and Fairtown. So if we label our triangle first with our small letters, we have side D, side E and side F. So what are we being asked to find? Let's highlight. So the distance between D and F. So we're basically being asked to find this side here marked with an E. So thinking about if we were going to use our sine rule, we would need the angle straight across from the side that we're looking for. Now we can fill that in because we know the 230 on the outside and we know the little 90 degrees just in the corner. So up in this top right corner here we can find the angle that we need. So we would do 360 minus 230 and minus 90. So that leaves us with 40 degrees. So in the triangle in here we have 40 degrees. So we have one pair already, we have the side and the angle. We then have one other side at the top, the 15. So if we were going to use sine rule, we would need the angle down at F. Now we can also fill that in because we can do the same on this side as we did on the right hand side to fill that angle in. So we know that's 126, and if we take away just the 90 we'll be left with just that part in the triangle. So that leaves us 36 degrees in this corner here. So we can now for F do 180 minus 40 minus 36 to get that last angle, so 104 at the bottom. So now that we've filled in everything we can fill in, we have everything we need to do sine rule. So we're going to go ahead and set up that calculation. So I'm just going to move the page up a wee bit. So we have E and we have F. So E over sine E equals F over sine F. So side E is the side we're looking for, so we'll leave that as an E. And then we have sine of the angle at E is 40 degrees. And then for F we have 15 for the side and the angle is 104, so sine 104. Now we will do our cross multiply and solve. So E times sine 104 is equal to sine 40 times 15. And then to get E, we just have to divide by sine 104. So sine 40 times 15 divided by sine 104. And as a value here, we get 9.9, and the units here would be kilometres. Okay, so this question here is 4 marks. So your first mark is for filling in the angles in the diagram. So you actually get your first mark for filling in the 40 and the 104 gets you a mark. Your next mark is then the correct substitution into sine rule. And then, as you'll probably be getting used to by now, your next mark is for starting to solve, knowing how to solve that, and then your final answer. So if you guys could please fill these in to your notes. I'm not going to give you any questions on these. I just want you to fill these in into your notes.